The question is the displacement in meter of a particle moving with uniform acceleration after t seconds is given by s equals to 27t plus 4.9 into t square. It is not t2, t square. Find the magnitude of initial velocity, acceleration, and final velocity at a t equals to 3 seconds. The major purpose of this problem is to understand the importance of differentiation. Okay, so how we will get it? First of all, what is the given? In the given data, displacement s bar is given. Why I'm writing s bar? It is a vector quantity, na? That's why I'm writing s bar. S equals to, what is that? 27t plus 4.9 into t square. T square. This is what given. And what we know about the relation between displacement and velocity? We know that velocity equals to rate of change of displacement. That's why ds by dt we can take it, ds by dt. So if we apply that, what we can write? D by dt of 27t plus 4.9 into t square. This is. So from the addition rule, addition principle, if you add it, what you can get? D by dt of 27t plus d by dt of 4.9 into t square. You can write like. So what is the formula, basic formula you can remember? The d by dt of k into some function. K into some function. Then what you will write? K into d by dt of f of x. That function you can write. This is the basic rule. That if you apply here, what we will get? The constant value you can take out common, 27. Then what will happen? D by dt of t value plus similarly 4.9 is also constant value, take out common outside. Then d by dt of t square will come, d by dt of t square. And here another formula which is in the differentiation we have to remember. What is that? D by dt of, or in x terms, if with respect to x, if you are doing d by dx of x to the power of n, what is the formula? N into x to the power of n minus 1 is the formula. If we apply that, what will happen? So t to the power of it, here you can find 1 is only 1. If nothing is there, only 1 you can expect. Apply the same principle. 27 into n means here for the first term it is a 1 into t to the power of n minus 1. N is 1 minus 1. 1 minus 1 plus 4.9 into, here in terms of n, what is there? 2. 2 into t to the power of 2 minus 1. That means what you are going to get? 27 t to the power of, again t to the power of 1 minus 1, 0. Anything to the power of 0 equals to 1 you are going to get. That's why you are going to get 27 plus and 4.9 into 2. That is going to be 9.8. And t to the power of 2 minus 1. 2 minus 1, 1. It is 9.8 into 2. So what is this? This is going to be the v value. But what is asked in the question? Find the magnitude of initial velocity. Initial velocity. When we can find the initial velocity, we can write that if velocity at t equals to 0, t equals to 0, velocity at t equals to 0, that is going to be turned into the u, initial velocity. Then in the above equation, of v, wherever t is there, you substitute simply 0. Then you will get u equals to 9.8 into 0. Then what remains? 27. What are the units of velocity? It is 27 meters per second, because it is a velocity. Then what about he is asking in the question, acceleration and final velocity at t equals to 3 seconds, right? That is asked. Acceleration and final velocity at 3 time equals to 3 seconds. That's why from the above equation, if we want get velocity at 3 seconds, I will get v at t equals to 3 seconds. V equals 3 seconds. What will happen? The final velocity v equals to 27 plus 9.8 into t. So in place of t, what we have to write? It is a 3 value. Then 9.8 into 3. What you are going to get? You are going to get as 29.4. 29.4. What is there initially already? 27 is. Then totally you are going to get 56.4. What is the final velocity at that 3 seconds? After that 3 seconds. So 56.4 meters per second is the final velocity. And what he's asking is another one. He's asking acceleration. Acceleration. What we know about acceleration? Acceleration equals to rate of change of velocity. Again, velocity term, what is there? What we have? D by dt of 27 plus 9.8 into t. So constant value, 27 is a constant. Na? You are going to get d by dt of 27 as a 0 constant, and another one d by dt of 9.8 into t. 9.8 you will take out common. What remains? D by dt of t will come. Then its value is going to turn into 1. Then finally what you are getting? A equals to 9.8 meters per second square. 9.8 into 9.8 meters per second square. This is the, what is the acceleration? What is the acceleration at that point, right? So whatever he asked in the question, the values we found everything. Velocity, initial velocity we got as 27 meters per second. And what is the final velocity at the 3 seconds? 56.4. Acceleration is this, right? So even though he asked in the question initial velocity, acceleration, and final velocity, why we find in UVA, not in the order of asking? Okay, of course, in asking, whenever initial velocity is there, if it has acceleration, then only we can get final velocity. That's why it was asked like that. I hope you understand it. Thank you.